In algebra, if I was to write x, you would know that it was 1x. Similarly, if I was to write x, that is just the same as x to the power 1. But we don't generally write these numbers. We don't generally write them, we would just write it as x. What we're going to do today is we are going to look at fractional indices. Fractional indices. Let's imagine that we have to calculate the square root of 36. How could we write 36 as something to a power of something? What would go up in that bubble there? So just as in algebra, when we don't write 1x, we don't write that x, we don't write that 1. Similarly with square roots, the proper formal way to write it would be with a 2 here and a 1 here. But we don't write that because we know what that means. We know that 1x just is the same as x. We know that these things are equivalent. This is going to lead on to our next formula. If we have got something to the power of m over n, we can write that as the nth root of a to the power m. For example, if we had x to the power 2 over 3, that is the same as the cubed root of x squared. If we had y to the power 5 over 4, that's the same as the fourth root of y to the power 5. Just applying this into my formula. One wee thing that helps me remember is just the n is at the bottom, that goes outside, so the n goes to the outside, so the n part stays outside. There is another way to show this as well, a to the power m over n. We can write this similarly as this here. Both this and the last slide, the last screen, are exactly the same thing. So if we had 4 to the power 3/2, what we could do is we could just do the square root of 4 cubed. The square root of 4 is 2, so we're doing 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. So it's really your decision which way you want to write it. You can write it as the nth root of a to the power m, or with the brackets. Personally, I prefer the brackets because I think it was more helpful in the long term when we're doing calculations, but it's entirely your decision. If we're to just look at a few quick examples, let's say we had to do 64 to the power a third. What we need to do is we want to first write it in one of these forms. So I'm going to write it in the form the cubed root of 64. And I could write to the power 1, but generally we don't write to the power 1. So I want to find the cubed root of 64. So I need to think, what times by itself 3 times is 64. So what times by itself times by itself? So if we think of 4 times 4 times 4, that would give me 64. So the cubed root of 64 is 4. Okay, here I've been asked to calculate 32 to the power minus 2/5. If we think back to our negative indices video, we absolutely need to have positive powers. Our formula was a to the power minus n equals 1 over a to the power n. So I can rewrite this with a positive power. So I can just rewrite that as 1 over 32 to the power 2/5. It's on the bottom, but it now has a positive power. Now I'm going to apply the law that I've just learned. So that's the 5th root of 32. And in this case, I'm going to square my answer. I'm not going to put the squared inside the bracket because I don't know what 32 squared is. But I think I can maybe work with it. So that's going to be 1 over the 5th root of 32. That means what times by itself 5 times is 32. So 2 times by itself 5 times is 32. So that would be 2, and then I have to square my answer because of this here. And if I were just to simplify this, this would come to 1 over 2 squared is 4. That is 1/4. So if you apply your formula properly, remembering that the number at the bottom of the fraction goes to the outside of the root, and the number at the top goes to the outside on the right hand side. If you can apply that, you should be able to pick up a few marks in your final exam.